welcome back, class. In our today's lesson, we are continuing to discuss about alcohols, and we have gone as far as reactions of alcohols. And the reaction of interest in this lesson, we are looking at dehydration of alcohols using a number of dehydrating agents as we have listed them on the board. The first example of the dehydrating agents that we can use is concentrated sulfuric acid at a temperature of 170 to 180. Another example is concentrated phosphoric acid in presence of heat. The third one is aluminium 3 oxide, which can be used at 300 degrees Celsius. If we pick out an example of an alcohol and see how it reacts with different dehydrating agents, the alcohol of interest here is called ethanol. Ethanol is an alcohol with 2 atoms of carbon, then with OH group at the end. When we expose it to sulfuric acid, which is concentrated, provided that temperature range 170 to 180 degrees Celsius, we convert our ethanol to an alkane called ethane. And because we are looking at the dehydration, the removal of water molecules, another product which is formed is water. At an advanced level, we take an extra mile and discuss what are the steps that we go through, or what are the steps that ethanol goes through to become ethane, and also we account for the second product, which is water. In that case, we are looking at the mechanism for the dehydration of ethanol. If we use our sulfuric acid concentrated, it undergoes partial ionization to become hydrogen ions and hydrogen sulfate ions. When we come back to our molecule of ethanol, the OH group has oxygen, and this oxygen has lone pairs, and this oxygen uses those lone pairs to attract hydrogen ion, which is positively charged. In the long run, our OH group has been turned into a water molecule, but the only difference between this and water is that our molecule of water is still having a positive charge on oxygen, and therefore we must neutralize that positive